Welcome to my video on petrochemical dairy. Today I will be treating the organic process of sulfonation. Without wasting much of our time, let's dive into it. First of all, let's look at the definition of sulfonation. Is the process where we replace a hydrogen atoms on an organic molecule with a sulfonic acid group. Now, if you look at the illustration I gave here, imagine swapping a sticker on a car. Now we are swapping a sticker on a car. That is just the illustration of what is sulfonation. Now, for us to understand this more clearly, for this to be more clearly to us, sulfonation is the process of introducing a sulfonic acid group, which is our SO3H, into an organic molecule, usually aromatic compound like benzene, toluene, or naphthalene. Now, sulfonation, brief definition, is where we replace a hydrogen atoms. Now we are replacing our hydrogen atoms on an organic molecule with a sulfonic acid group. So the other definition, we said the organic molecule can be benzene, toluene, or naphthalene. Now let's look at the diagram here. Now we are looking at the sulfonation of benzene. So we make use of benzene as the organic molecule. So we know that benzene has 6 carbon and 6 hydrogen. Now, according to the definition of sulfonation, we replace one hydrogen that is here, where this benzene lose one hydrogen. That means remaining 5 hydrogen that is here. Remaining 5 hydrogen that is here. So that makes this benzene negatively charged. So it makes this benzene negatively charged. So that means this benzene is looking for an electron. It's looking for something to fill that place of that hydrogen that is missing. Now, this our SO3, which is the sulfur trioxide, it now come in place and replace that hydrogen that is missing. It replaces the hydrogen that is missing to produce our benzene sulfonic acid. Now this acid that is here, which is our H2SO4, is an important acid. It's a sulfuric acid that helps the reaction. It produces this our SO3, which is our sulfuric acid, which is our sulfur trioxide. So we understand this, that this our sulfur trioxide, it come in place, it replaces the hydrogen that is missing in this benzene to produce our benzene sulfonic acid. Now this is a type of electrophilic aromatic substitution. Now what is an aromatic substitution? Now before we go into the definition of aromatic substitution, before we go into the definition of electrophilic aromatic substitution, let's look at what is it. Electrophile is a molecule that has a tendency to attract or acquired electron. That means they accept an electron, but also they are electron deficient. Now electrophile, they have the tendency to accept electron and negatively charged. Now we have what is called electrophile or nucleophile. They are electron donor. They donate electron. They donate an electron. So they are electron donor. Now the difference between nucleophile and electrophile is that electrophile they accept, while nucleophile they give out. That is the difference between nucleophile and electrophile. So electrophile accepts electron, while nucleophile give out electron. So for us to now understand this electrophilic aromatic substitution, so let's define this aromatic. Electrophilic aromatic substitution is a fundamental organic reaction where an electrophile replaces a hydrogen atoms on an aromatic ring, typically benzene, to form a substituted product while retaining the ring stability. So this electrophilic aromatic substitution, it explains this diagram that is here. Now we said the electrophilic aromatic substitution is a fundamental organic reaction where an electrophile. Now Electrophile is this SO3 that is here. Remember we said electrophile, they have tendency to attract an electron, don't to accept an electron. So that is electrophile. So we see this SO3 that is here is our electrophile in this reaction because they accept an electron. That means they are the one that replaces the hydrogen that is inside this benzene, that is in this benzene. So since they are the one that attack this benzene, or they are the one that replaces the hydrogen atom that is here, that make them an electrophile. Now it transforms the reaction, the electrophilic aromatic substitution transform simple hydrocarbons like benzene into water soluble acid, which is our benzene sulfonic acid. Also, which is the first step in making many useful products. We'll come to that. So we see this reaction that is here. This reaction, it must be involved in this reaction. For this reaction to occur, it must be involved, and usually it require high temperature. So also this reaction is a reversible reaction. That means this benzene sulfonic acid can reverse back to produce our benzene. So for this to occur, we react this benzene sulfonic acid with water or diluted acid to reverse back to produce our benzene back. So let's look at it. This reaction requires a powerful acid to work. We typically use concentrated sulfuric acid, which we have explained, and then we also use sulfur trioxide. We have also explained that often these are mixed to create foamy sulfuric acid. When sulfuric acid and sulfur trioxide, when they are mixed, they create foamy sulfuric acid, also called oleum. This mixture is super reactive because it is rich in SO3, which is our electrophile or the attacker in the reaction. Now let's look at the mechanism. Step 1, we see that the reaction reacts to produce a strong positive particles, sulfur trioxide. Now the acid that we have explained this before, the acid produces a strong positive particles, which is the sulfur trioxide. This is our electrophile or electron lover. We have explained this before. Now step 2, the attack. Now the benzene ring, which is a cloud of electrons, like we said, the benzene ring have 6 hydrogen and 6 carbon. That means they are a cloud of electrons. So like I said before, when the hydrogen is loose, when the hydrogen is moved from the benzene, that making it 5 hydrogen that is left. So this is our electrophile, which is the SO3, the sulfur trioxide will now replace the hydrogen in the benzene. So that makes it the attack. So our sulfur trioxide attack the benzene. So when it attack it, this break the ring stability temporary. The step 3, we are talking about the reversible reaction. So like I said, the reaction is a reversible reaction. It can reverse back to produce our benzene. So the benzene sulfonic acid is used in many production. So it's used in the production of detergents. It's also used in the production of dyes, and it's used in the production of medicine. So in this video, we have understand about the sulfonation of benzene, the reaction of the sulfonation of benzene. Now, one thing that we understand in the video is that the reaction is a reversible reaction, which I've said before. Unlike many reactions, sulfonation can be reversed by adding hot diluted acid. So the process of this when the reaction is reversed is called desulfonation. Like I've said before, the reaction requires heat. This process is slow and typically need elevated temperature to proceed efficiently. So it requires heat to proceed efficiently. Also, the reaction are industrial giant. It is one of the most important reactions in industrial organic chemistry, producing millions of tons of material annually. Like I said, it is in production of dyes, detergents, and medicine. Now, the reaction also are electrophilic in nature.